Hello and welcome to this lecture in which we dig a bit deeper into how infrastructure as code works. Now again, this is a huge topic in the cloud. This is something that only the providers could do a few years ago, but nowadays we can control the cloud as we wish. And it's really important to get a grasp and get an idea of how it works and about some of the tools that are involved in all this infrastructure as code mechanism and concept. So let's take an example. Let's see again some of the main tools that are involved when dealing with infrastructure as code. So let's say that we are working with a cloud provider. Could be anything, could be AWS, could be Azure. Hello. So we have the cloud provider, with everything that it has to offer. And the first thing would be let's also add ourselves, so that that would be us, the actor. So the first thing that the cloud provider does in order to enable us to create some resources, so we want to spin up some virtual machines, some volumes, some functions, could be anything, some resources, is to expose an API. Let's actually use something else. So let's use this. So they expose an API. And that's also what they use. That's how they create resources, that's how they provision virtual machines, that's how they manage databases and everything that happens. So basically they abstracted their infrastructure through an API. And they will expose an HTTP interface. Let's again use this. So they will have some HTTP endpoints allowing us to consume the API. So we can just call those endpoints and tell the provider to create something. And that can be a good starting point. So we can just, again, use curl, use Postman, use something else, make the HTTP endpoints. Of course, after consulting the documentation of the provider, they will have a reference for the API. And we can just create, destroy, update, get the resources that we created. Now, of course, this is not ideal, especially when getting started. So when we start, we probably will use something else. We probably use the web console. So let's also add that. Web console. So we have the web console, which behind the scenes consumes the API. There's no magic involved. It just does the same thing, but in a nicer way, in a more user-friendly way. So it gives us some buttons, some tables and lists and so on. So we don't have to deal with the API. Oops. Okay. Again, good starting point. If all we want is a single virtual machine, we can stop here, but we probably want something more. We probably are part of a team. We probably have multiple environments. We probably have an infrastructure that changes on a daily basis. And clicking around the web console is not ideal. It's also error prone. It's really easy to miss some checkbox or something like that. So again, not ideal. Something else that we can do, we might have, so let's say this is our local environment or local machine, or could be a build system. And here we can leverage the SDK, Software Development Kit, which behind the scenes simply, I keep forgetting where the hexagon is, simply abstracts away the HTTP interface. So we can leverage the SDK instead of the web console. And we simply, so basically the SDK is a library that we can include in our applications, and behind the scenes, again, it will make the calls to the HTTP endpoints. And this helps us especially when thinking about versions, for example. So every now and then, cloud providers will release a new version of their API, adding more features, deprecating something else. And we have, if we consume especially the HTTP endpoints, we have to keep up to date. We have to read the documentation, we have to read the news and so on. But using the SDK, we just update the library and that's it. Of course, we might use a new class or a new function and so on. But again, it abstracts away the complexity. But again, this is not ideal because we still have to think about the order in which the resources are created, because some might depend on other resources. You know, we might create a firewall and a database, and we might have some virtual machines that use the database and also that use the firewall. So we have to create those before the virtual machines. And that's something in this scenario we would have to worry about ourselves. And also we have to create the script or create the application that uses the SDK. However, there is another way to do this. So we have the CLI. We might leverage the CLI, which of course internally uses the SDK, but it enables us to just install the CLI, open the terminal and start issuing some commands. So it's getting better. We no longer have to code anything. We no longer have to maintain some code. We just have to install the CLI, figure out which commands to issue, and that's it. But again, we still have to manage the state. We still have to manage the dependencies between resources. So again, this might not be ideal. Another approach, or actually at this point we start actually talking about infrastructure as code, is to leverage what the cloud providers offer. And this would be their native services dedicated to infrastructure as code. Could be CloudFormation. In case of AWS, could be Azure Resource Manager for Azure. Could be Deployment Manager, I think it's called, for Google Cloud. And at this point, we no longer issue commands. We no longer explicitly tell the provider how to achieve something, but rather we just describe what we want. So we move into a declarative approach. Let's get rid of that. So instead of running commands through the CLI or calling some functions from the SDK, we just have some files in which we declare our desired state. So those files could be in JSON, or it could be in YAML, or it could be HashiCorp configuration language. We'll talk about that in a minute. And those files are fed through either through the, actually let's reuse this. So we can directly feed those files to the YAC service through the web console. So they are integrated. There will be a page for CloudFormation, for example, where there will be a field in which we can upload our templates. And behind the scenes, the service will manage the state. So we have the state in here. It will figure out the right order to create resources. It basically does everything for us, which is fine. But of course, if we have a build system or something, using the web console is not ideal. So at this point, we can start using the CLI again. but instead of telling how to achieve something, let's get a new arrow. So instead of issuing certain commands to create virtual machines or do something specific, we just feed the CLI the templates, the desired state again, which in turn will feed them to the service. Well, actually through a dedicated HTTP endpoint, but it doesn't directly call the API, but rather calls the API of the YAC service. And at this point, it's already pretty good. I mean, this could be our final, or not final, but we are already in a pretty good state. So that's using the services offered by the providers. Now, another approach might be, you see, so we have here the HCL. We might describe the desired state, the resources in HCL, HashiCorp configuration language, and use the Terraform, which again is a CLI and an infrastructure as code tool. Terraform. And at this point, we no longer use the cloud's the provider specific service, that's gone, and also the state. We'll talk about the state in a minute. So Terraform will know how to consume the HTTP endpoints of the provider, and it will also store the state. It will manage the state for us, and it could manage the state locally. So it could be on the same machine, for example. If we use the Terraform CLI on our laptop, it could save the state on our laptop. Of course, it also figures out the dependencies between and the order of the resources. But of course, if we are part of a team, if multiple persons are working on this, storing it locally on our machines is not ideal. We have to share it somehow. So we can leverage something like Git. By the way, in the case of Terraform, the state is just a huge JSON file. So we can store that on Git, for example, or we can store it even on Terraform Cloud. So that's the offering of Terraform that knows how to manage the state, that knows how to run the scripts, not the scripts, but the templates. Or we can leverage, for example, the object storage services offered by the provider. For example, S3. We might use S3 to store our state. So Terraform will know where to look for the state. It will, before doing anything, before we update our infrastructure, it will reconcile the state. So it will look into the JSON file, and then it will make the HTTP calls. So it will try to see if we have done anything outside of Terraform. So maybe through the web console, we modified some of the resources. Again, that's reconciling the state. And then it will figure out which are the changes that it has to perform. And again, that's a pretty good option. Now, Terraform might be the only approach in some cases. For example, if we use something like UpCloud, for example, which is a cloud provider from Europe, an amazing cloud provider. So they don't have something like CloudFormation. They don't have something like Azure Resource Manager. They just expose an API. They do have a public API that can be consumed, and they have implemented a Terraform provider. That's how it's called in the Terraform terminology. So basically, some code that knows how to call the HTTP endpoints. And we could use the Terraform in that case. And also another consideration regarding Terraform and the cloud native services is that regarding, again, the versions. So whenever the providers release a new version, it might take a bit of time until their services, CloudFormation for example, adopts those new changes. However, Terraform being open source and everyone can contribute to the providers again, to the libraries basically that abstract the HTTP interface, the API, might get those new features earlier than the actual services of the provider. Of course, in most cases, it's a matter of few days, but still, it could be a valid consideration and a valid reason to use Terraform. So I hope this is helpful. I hope this makes all this Yak story more clear, and I'll see you in the next lecture. Bye.